Whatever. Wouldn't you know it? I take the dog out, and it comes back smelling like a skunk. The little, the little devil dog. What the hell is that noise? That's crazy. Try to work with this camera. Okay, I don't know what that was. I was just realizing something. Sorry. Um, trying to put the camera in a spot that will better help the situation. Okay, I think that might work. Okay, so what is happening right now is I had to take this transistor, and right now it is acting as a transistor and it's transisting. Um, but apparently in this machine, because there's no schematic on this available, I had to figure out that that's not what's supposed to be in here. What's supposed to be in here is a transistor that is reverse biased, and what it does is it creates a pulse, and it kicks over the high voltage, and I think it's supposed to uh, keep keep the high voltage. And I'm having this issue where every time I turn on the radio, the high voltage gets dragged way down, and when I transmit, it gets dragged down even further. And I'm hoping this will solve that. This is dead. This has nothing to do with this. Um, it came with the PMP, and I'm wondering if I should put that PMP back in. But I don't think I need to. I might need to. Um, so if we think about this, the emitter has to go to ground. On here, this would be the emitter. Right now it's not going to ground. It is going to... It is actually going to an in-between voltage, not ground, um, and not 12 volts, so probably like 5 volts. It was set to bias this. Um, so right now I'm trying to figure out if I can use an NPN or a PMP, if it matters. I'm hoping it doesn't matter. So right now with this NPN, the emitter should go straight to ground, and the collector needs to go between two resistors. Um, this would be the collector right here. The base isn't even on it, so it shouldn't matter if this is the NPN or PNP. So I should be able to proceed with this. Now these resistors, let me formulate a plan for these resistors. So this is the base that we'll cut off. We won't even worry about it. I'm not going to cut it off. I'm just going to leave it out. We'll leave out the base. When I opened this radio up, it was kind of wired like it is now. So I'm really wondering if somebody was in this radio before and was trying to fix it. I have no clue. This is weird to me. Um, this high voltage circuit operates without this transistor. All this transistor does is bootstrap the high voltage, because it won't turn itself on. It needs a pulse to turn itself on. And this is supposed to give it that pulse. The values, when I did it over here, were quite high. They were all the way at 50K. Is that what that is? Um, Let me see. This is the test circuit that I made. Let's see, 5 0 and 4 zeros. 500K. I used 500K, and those almost weren't enough. So definitely not going to be able to use these resistors that I have in here. But if they're at 500K, then they're not going to have to dissipate heat, and they can be quite small. Where do I pull that pulse from? Oh, in this circuit, I forgot the diode. There's a diode in here, actually. I don't know if that matters. I don't know if it's got to be in here. But let's see, where is it coming from? It is going from this is supposed to be the emitter, and this is the collector. Okay, so the diode goes on the collector. Ah, I see. So the positive of the diode goes to the collector. Where is my pen? Okay. The positive of the diode so actually I can write it in just like that. Pretend it's like that. Where do I get my pulse from, though? It's going to have to be between... These are PMPs. They want a positive, right? How did I forget that? I'm pretty sure. Let me look at my book. PMP needs... And NPN needs a positive on and a negative off. So that means PMPs, like I have in here, they're going to want a negative pulse to turn on. So we're going to need this. We're going to need to drive a negative going pulse to push this thing into oscillation. Wait, what the hell is this? I just realized something. This is not what this is not what it's supposed to be. This is the complete wrong circuit, because the base isn't supposed to be hooked up. What the hell? Where is the circuit that I'm supposed to be? I think what this is a circuit that I designed that I thought would oscillate, and it does not. I mean, I think it does, but it oscillates at like microvolts. So what is all this? More crap. The Zener. I never drew. I need to try and move. I don't know if that pauses it or what. Oh, hey Solace. I'm working on a. I don't know if you're still here, but I'm working on an old boat radio. Has tubes and stuff. This is the power supply section. It creates 200 volts and then steps it up to 400 over here. Huh. Maybe the stream paused. I have no idea. But I got the schematic. And that's what we need to do. Off the page is ground. I accidentally ran out of room. Okay. So now, the emitter, which is that, is going to go to positive. And the collector now I'm wondering how sure I am that that is actually what that is. Let me get the damn soldering gun in here, and I'm gonna put the tester on it, and that will solve that question. Pop that on. Someone once commented, they said, why do you even put this stuff on YouTube? It's so boring. You wasted my time. And I'm like, it's a live stream. I didn't promise it would be entertaining. But also, I didn't put live stream in the title. I guess I just assumed YouTube would do it automatically. But also, when you click on it, you can tell it's a live stream because it has the chat. Okay. Sorry, I was plugging all those in. And excuse me, the soldering iron's heated up. Oh man, I need hemostats or something. Tweezers. All my stuff is disappearing. Not okay. Not okay at all. Okay. I'm gonna have to use my bare fingers, I guess, so prepare to see me get burned. Alright, I'm gonna move that out of the way. That resistor, I don't know what that resistor is gonna be doing. So let me move that. Let's get this capacitor out of here. Okay. It's done. That is hot. Okay. Try to pop this stupid resistor off. Okay. Now, here is the tricky part. The tricky part of lifting this up off of this base. Yoink. Oh, yeah, so tricky. That was so tricky. Oh, yeah, burn everything too while you're at it. Actually, this resistor is kind of kicking my ass. Get off of here. It is looped on. That is great. Maybe if I undo it and keep it moving while it dries? No? No, I need you out. I need you gone. Hey. Nope. I give up. I'm using my bare fingers. Ow, that was hot. Got it. Ah, calluses are great. Now with this extra long lead length, I can bend that back up. Okay. So, where this outputs is right here. I just realized something. Oh, snap. Uh-oh. I think I screwed up. Alright, let me think about this. I think what's got to happen is I need a gate, and that gate needs to put a negative pulse, and I'm not gonna get a negative pulse from this. So I'm gonna need to build this circuit and use this transistor as a buffer, I believe. What were they trying to do with this transistor? I can't imagine. But if I try to build it out this way, like there's a 20 ohm resistor in here. There would be a bigger resistor there. That big old Yankee. And it was backwards. Everything was backwards. It was a PMP. I need to get that. I need to find that PMP. Because this is all set up for PMP. Oh, thank goodness. It's right here. Okay. And look, it's labeled. All that yapping I was doing about not knowing. Okay. So it will go this way. And it was hooked up like that. Okay, these are backwards, I think. Or I was backwards. No, I'm stupid. Okay. That will go like that. And that will be fine. Let me draw the PMP schematic version of this, so that way I don't get confused. Because being confused... Yeah, just realized to you guys, I'm drawing crooked as all get out. Let me try to fix that. There we go. We'll draw... Should we draw the battery backwards? Draw the battery backwards. This is ground now. Positive is now ground. Yep. Okay. Good. We have a battery. Great job. The transistor is now a PNP. The emitter... Okay, I'm stuck. Crap, I'm stuck. How is this gonna go? Does the emitter always go to positive, no matter what? I don't think so. Oh. Oh. Okay. It's a PNP. I need to think about it like this. P, P-type, P-type, N-type, P-type. Okay. P-type, N-type, P-type. N-type, it wants a negative pulse to turn on. The current goes from I need to convert to the book on this one. I actually have that stuff drawn out. Is this it? I think this is it. Which way the current flows through the diode. Okay. The N-type is the cathode. So the current flows from the N-type to the P-type. Current will flow from the N-type to the P-type. Good, good, good. So if it is a NPN, the current will flow from the N-type to the P-type. So we can use that information to figure out which way this transistor goes. I don't think it actually matters in this case. As far as the diode goes, the diode needs to be to ground no matter what. So let's do that. Let's put the diode to ground. Nope, I'm screwing up. I am screwing up. I am screwing up. That does not go that way. It goes this way. Like that. Okay. Perfect. So far, so good. We will still have the resistor right here. Yoink. Our capacitor will be here. So far, so good. So that means our collector is still over here. I mean, our emitter is still over here. I think that's what that means. So I just drew the exact same circuit. Okay, so it doesn't matter. Then the only thing that matters is which way you place the diode. Alright. The diode goes from the collector to ground. This outside case is the collector. So we will have from collector to ground. Ground is over here. Even though there's red wires right there. This is ground. I think I can leave that NPN in there. I don't think it's going to matter. The pulse when I grab it, how should I grab it? Right here? This is gonna be weird. And this is on the collector side, so it will go from the collector, jump from the collector over to here. When I first got this radio, this thing was set over here, and I think it went from here to here, and I thought this was going to the base, but it wasn't going to the base. It was always going to the whatchamajigger, and the base, what was the base hooked to? What was the base doing? The base was hooked to the collector, actually. Yeah, so that had me really confused when I first opened this thing. And of course, when I fixed it, it didn't work. It didn't work at all. It didn't work the way they had it, so I just couldn't figure out what was up. But apparently, let's see if we can just give it a try. Oh, snap. So this is the emitter, and according to the schematic, we want positive to go to the emitter. I don't think we need 1K. We might. Trying to think about that. Yeah. Okay. Yeah, we need that. We need that because it's charging the capacitor. The 4 microfarads that was in here. Let me find. That's 47. Daddy. When I say 4, I said 4. Because here it is. 4. I'm stupid. I didn't see the decimal point. Forgive me. Okay. Here's our 4 microfarads. And that will go somewhere. Let me get that 1K resistor from our Bojack box. Go Bojack. Cheap resistors. 10K. 22, 47, 2K. Actually, let me try 1K, actually. Let me just go with the dang schematic for once. Oh, we are way out. Okay. 6K. 1K. Here's our 1Ks. Who said I can't read Russian names. Wish I could. That would be nice. Alright. So, 1K. Used to be a resistor across this. Wonder why. Could not tell you. The 1K ties to this. The positive of this and this will tie to the emitter. So we will get this touching on the emitter after I suck up some solder. Gross. I screwed that up. This solder sucker hasn't been sucking solder very well lately, I feel like. Ah, snapper. How the heck did that come apart? You crack-neck and lacquer. Alright. I'm trying to twist the parts together. Sorry, it's off camera. Gonna have to do some weird soldering skills. Like this. Alright. Perfect. Got a little blob on there. And we will take that to the emitter. Perfect. Okay. Now. Should be good enough. Good enough for testing purposes. Okay. Now, the capacitor goes to ground. Nice, nice, nice. We got that done. Now we can focus on the collector, which has a diode on it. I happen to have a diode that emits light somewhere. Had to find it. Could use a signal diode, I imagine. But I kinda don't want to. I kinda want to use an LED that I can't find, so I'll just pull this one out of here. And we'll use this one, this yellow one. It'll probably burn out in the blink of an eye. Okay. It is supposed to go from the collector to ground. This is an NPN, so yeah. NPN. It will go this way. Yoink. Try and two thingamabobbers. Let me tin these leads out. Alright, sufficiently tinned. Oh crap. I missed by a little bit, but that's okay. Bent it back up. And I think we're almost ready to test this. I think that's good enough. Perfect. So, that looks done. We'll have to pull the signal out of it and, oh god, where am I gonna put the signal at? Oh, snapper. I'm trying to think. There is 20 ohms on that right there. I think I am screwing up. Where does that pulse going to go? I could put it straight into the base. I think that's what I'm gonna do. I'm gonna put it straight into the base of one of these guys. Maybe I should do that. Maybe let's turn this thing on and we'll play with some resistors and touch them to some stuff. Because that's 1k ohm. I could bring it right back around and slap it in here. We'll try that. I only need to power up the high voltage supply, so that should be easy enough. We are at 10 volts right now. Plug in the high voltage supply, you will hear it whine. Oh, don't hear it whine actually. I do see the LED lighting up though, which is good. So if I don't hear the whine, that means it's not triggering, so I would have to trigger it myself, because there's nothing triggering it. That's what this button's for. Which I don't think is working, because I undid all this stuff. So the LED is glowing a little bit. So that should be putting out a pulse. Let's see if it's putting out a pulse. Let's open the oscilloscope. We can see the scope down there. And I'm going to touch around for a pulse. I gotta get this thing grounded out. Let me ground the ground lead. I smell burning. Is it coming from this? No, it is not. Nothing's burning, thankfully. I think it's just the... Alright, we're grounded out. Let's test. I am poking the collector. Okay, we're on it now. That might be the 60 hertz oscillation. Yeah, so that's not what we're looking for. Okay. What the heck? Why is my scope acting weird? Alright. I still see the glow. No pulse. No pulse there. No pulse there. No pulse there. Let me add some capacitance. Like a 0.01 mic. I don't think that's gonna work. Let me try a 47 mic. See what that does. Well, it turned the LED off, and it's staying off. But I also put this cap backwards, so, okay. The LED is dimly lit. Let me touch. No oscillation. Okay. What does this mean? Do we have to put more current into the transistor? Let's add another 100 ohms. I mean, K ohm. So it'll be 500 ohms instead of 1K. Maybe that'll put enough current through it to get an oscillation. Let's turn that light out so you can see it dimly lit. Now it's a little bit more. Oh, wait a second. Hold on a second. How did I do that? I hooked it up to the base. I hooked the diode up to the dang base. Why did nobody tell me? How the hell did I do that? The diode is supposed to go. Wow, yeah, I really puffed that one up. Oh yeah, it was supposed to go to the damn collector right here. I even had to do my super soldering skills to get this on. And the whole time I was putting it in the wrong spot. Alright. Well, let's put it in the right spot this time. Oh, come on now. Dude. Put the solder on the skin. or else it gets the hose again. Hello. There it is. Oh, got it on. It is not flashing, but that's okay. It could just be very high frequency. Let's check the scope. Oops. Checking scope. Yeah, I'm not getting anything. It is more crap. Okay. Try some more capacitance. If we get a good slow blink out of it, that means it's working. Recurrent? Huh. I wonder if I should take the 20 ohms out. I mean, if I should take it out of circuit with the 20 ohm. Put it over here. Oops. Big stick. You know you want to. Dang it. Now it'll stick. Very dimly lit. No oscillations. Could we possibly be backwards? It's possible. Is it? I don't think so. So, either there's too much current, which we can definitely try that. We can do 2K. How many volts? It's a 50 volt cap. Where are my nippers? Damn nippers. You know, here's my nippers. Okay. Cut that off. And everybody ready for the eclipse tomorrow? And this. It is now 2K ohms. Nothing. Alright. think about this. Not blinking. Maybe it's backwards. I think let me try to throw a different configuration. All that needs to switch really is this. So it will flip. And it will go here. Alright. And then the resistor and capacitor. Let me do a big one. 47. That way we can see it good. Oh my god. Okay. The diode needs to go to positive. Yes. Yes, yes. Yes, no, maybe so. Here, we'll use this wire. This old wire. So, diode is not lit up. Damn it. I don't see any light. Maybe. Maybe it goes like this. Oh. It lit up. It's continuing to light up. Okay, what does this mean? It should charge the capacitor, and then it breaks down, and then discharges. 1K. So the resistor should not be, the resistor should be in between. So maybe my capacitor is now on the wrong side. Okay. So I don't think it should be on right now, or maybe not. Let's see. It kind of looked like it oscillated there for a second. Drain the cap. It blinked. But that is no oscillation. Huh. What do you suppose that is? Dang. I don't know what's going on with that. What's it doing? Strange. Okay, now back up the other way. And see. Now I want to short out to the base. Seems the current goes down, but not an oscillation. Let me short it. Oh, it goes up this time. Let's see if there is anything there. Nothing. 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 Oh, nothing. Oh, cool. Oh god, it looks legal. That's kind of fun. I don't really know what to do. Whoa, that killed it. That killed something. That was 12 volts to the base. This diode is barely alive. I think I should test to make sure I didn't kill this transistor. Hard to tell. So here's what I'll do. Bring in this and grab another LED here. Guess we're going with red this time. Follow this schematic. Apparently this should work. So, this is the emitter. This is the collector, right? So the collector has this diode, this emitter, light emitting diode. What's going on? My brain is in a fog. Cathode to ground. Okay. Very well. Cathode to ground. Base to nothing. The emitter gets a capacitor. The original schematic said 0.01 microfarad. And it also goes to ground. Okie doke. There's a resistor, 1K ohm. Here's our 1K. It goes from positive to the emitter. So like this. think I hooked that up, right? Red. Black. Don't think this diode works, son of a bitch. Let me check and make sure. I'm even getting anything. I'm getting 10 volts. The damn diode is dead. I'm sick of dead diodes. For real. Now I'm gonna have to re-up on LEDs. How the hell am I gonna do that? I don't want to use this green LED. It's a pretty green LED. And I refuse to use it. So. I'm gonna have to find one elsewhere. Found one. Don't know what color it is, but it's an LED. And my battery's dying. Let me plug it. Plug it in, plug it in. Do they even have that commercial anymore? I don't watch TV. Quickly remove that diode of the light emitting variety. Perfect, and it works. That looked a little orange. That I might be overvolting it. Hold on. Amber. Okay. I like ambers. Let us see if it does its job. Okay. Now, take the scope and look for oscillation. Check that out. Finally, after all this bullshit, there she is. Come on, phone, focus. You're focusing on the wrong thing. There we go. This is an oscillator, a single transistor oscillator, and it is supposed to tickle this high voltage circuit in this radio, because I'm having issues. The high voltage circuit isn't staying high voltage, so I'm putting in a new tickler in it. It's called a bootstrap. Let me put a different capacitor in here and see what we get. Let's try and raise y'all up so we can see capacitors. We are doing a 0.1. This one is 0.01, I believe. No, it is 0.1. Let's do a 1 microfarad capacitor. If I can get it out. There we go. And I'm like, that should, in theory, change the characteristics of our output. It does. It did a lot. What is that skew? Okay, that's 60 hertz noise. We can ignore that. Yeah, this capacitor ain't doing it. Let's do this. 150 ohms, 120, 300, 47, 2K. Let's try a 2K resistor. See what happens. Yoink. I think I should put the original. Why is it on right now? I don't think it should be on right now. What does it look like when it's doing that? Alright. I lost that stupid 0.1 cap. I got new one. Alright. Let's get that back in there. Yeah, it doesn't look good anymore. What happened? But I need to put that 1K back. Alright. And there it is. It is riding the 60 hertz, and it is very not good. Let's try 100K. There we go. Oh, and that's dead. Oh, why does that turn it on? Oh. It just turned itself on and turned itself off. Well, that's not okay. Alright. 22K. The heck? Somebody is shooting something weird. Yep. She don't look good. This is definitely 60 hertz right there, because it's everywhere. What the hell? Oh my god. What is going on? I think somebody's setting off bombs. There's so much smoke. What the fuck is going on outside? Holy shit! What the fuck? Oh, I will be back.